electronic copy of the textbook? Did the university contact you or they sent you a link? Nobody received the link? Yeah, لأنه yesterday we had a meeting with the administration. They told us they are in their way to send you the links to download the textbook. So it's not. Okay. Let's continue now. This is, so remember, this is the input, which is Q here. And then the output, which is Q2, the output. Q2, the output. So at steady state, the flow rate throughout the liquid level system shown in figure is Q bar. This is the steady state value. And the heads of the tanks 1 and 2 are H1 bar and H2 bar respectively. At time t is equal to 0, the inflow rate is changed from Q to Q bar plus Q. Okay, this is Q bar, where Q is a small amount. The resulting changes in the heads H1 and H2 and flow rates Q1 and Q2 are assumed to be small. The capacitance of tank 1 and tank 2 are C1 and C2 respectively. The resistance of the outflow valve of tank 1 is R1, and that of tank 2 is R2. So basically, what do we have? We have two tanks and two pipes, tank C1 and tank C2, and pipe R1 and pipe R2, and we need to find this equation for this system. So the equation for the liquid level system, for the first tank, tank 1, we can write it like this: C1 dH1 over dt. So it will be Q in minus Q out. This will cancel. For the tank 2, it will be C2 dH2 over dt. It will be Q1 minus Q2. Remember, we have Q input minus Q output. When you talk about so the tank 1 here, the tank 1, the equation for this one will be C1 dH1 over dt equal to Q1, the Q input, minus Q output. Q output minus Q input. Q1 minus Q. Similarly, here we'll have C2 dH2 over dt, the rate of change in the volume, will be equal to Q in minus Q out. So Q in here is Q1 minus Q2. I think should be this one, Q minus Q1 here, and Q in minus Q out. So these are the equations for the two tanks. If you see here, Q in minus Q out and Q in minus Q out. You can write them like this. C1 will be dH1 dt, Q minus Q1, or Q minus the pipe 1 will be H1 over R1. We need to write the equation for pipe 1 here. H1 over R1 will give you Q1. And this one here, R2, we have H2 over R2 will give you Q2. So we have four equations. One equation for this tank, C1 dH1 over dt equal to Q in, yani Q minus Q1. And for this tank, we have C2 dH2 over dt will be equal to Q1 minus Q2. If we substitute Q1 by H1 over R here, and we substitute Q2 by H2 over R, لأنه we are asked now to find a relationship between Q2 and Q. So the flow rate, output flow rate over the inflow rate. So this is what we get here. So if we substitute R1 by H1 over Q1 and R2 over H2 over Q2. The first equation will be like this. C1 dH1 over dt is equal to Q minus Q1 or Q minus H1 over R2. Remember, we want to arrive to this relation. We want to arrive to Q2 over Q, which means the output flow rate over the input flow rate, where Q2 is the output and Q is the input. Similarly, we will find the equation for the second tank, C2dH2 dt will be Q1 minus Q2 or H1 over R1 minus H2 over R2. Remember, Shabab, here we need to find the relationship between the output and input using the physical quantities. What are these physical quantities? The physical quantities we have the tank C1, tank C2, and the resistance R1, pipe 1, and R2. So our transfer function will be function of only these parameters, which means we need to get rid of, since we are asked for to find Q2 and Q, so we need to get rid of H1 and H2. Now, if we add these two equations, if we add them, we are doing this process to get rid of H1 and H2. If we add these two equations, we get this one, C1 dH1 over dt plus C2 dH2 over dt, Q minus H2 over R1. And when we add them, this will cancel with this. So we'll have Q minus H2 over R2. Now, again, if we differentiate equation 2 with respect to time, if this differential, we differentiate this equation with respect to time, we find C d2 C2 d square H2 over dt square plus 1 over R2 dH2 over dt will be equal to this one. All this, we are doing this process just to get rid of H1 and H2. So at the end of the day, if we eliminate dH1 over dt from the previous equation, we got this equation. R1 C1, R2 C2, the second derivative of H2 with respect to time, plus R1 C1 plus R2 C2, dH2 over dt plus H2 is equal to R2Q. Now you see, Shabab, we have only, you have Q and we have H2. But H2, we can find the relationship between H2 and Q2 by using this equation. H2 will be R2Q. So if I substitute H2 by R2 times Q2, I can find the relationship. So if I substitute here H2 by R2Q2, R2Q2, R2, I can find this equation. R1 C1, R2 C2, d square Q2 over dt square, R1 C1 plus R2 C2, dQ2 over dt plus Q2 is equal to Q. Now, if you take Laplace transform of this equation, you will have the following. You will have this equation, R2. I will call Shabab Hina to make it easy for you. I will call R1, C1, I will call them, this one will be equal to tau 1, constant tau 1. And I will call R2, C2 is equal to tau 2. So to make it easy, to make life easy for you. So now this one will be tau 1 multiplied by tau 2, tau 1, tau 2. If I take Laplace transform of the second derivative, it will be S square QS plus R1 C1 will be tau 1 and then plus tau 2. We will have QS also. The second derivative will be S QS, okay, plus the Q2 plus 1. And then this one we will have Q2 as common factor. Q2 will be equal to Q. So if we take the ratio Q2 over Q2 of S over Q1 of S over QS, the output over the input, it will be 1 over. This one, Shabab, we're writing tau 1, tau 2. We can write it like this, tau 1, tau 2, S plus 1. Sorry. We can write it like this, tau 1 as null. So I will write it again. So I will write the transfer function, if you remember, I will write it again in this form. So Q2 over QS, we'll write it 1 over tau 1S plus 1, this is 1, tau 2S plus 1. This is what we have. Exactly, this is what we have. And this is, as you can see, a second order system because we have S square here. So this is how to differentiate the differential equation to get it, and how to get the transfer function between the output and the input when we have a parallel tanks. Any question? So it just differentiate, just take Laplace transform of this differential equation. This one is only a differential equation, and the definition here, as I gave you the definition, it will be easier if you consider that tau 1 will be equal to R1 C1 and tau 2 equal to R2 C2. Just to R2 C2. Just to eliminate the too many variables, because it will look cumbersome and compact. So here, the transfer function is a function of the first pipe and the first tank, the second pipe and the second tank. We don't have in the transfer function any of the parameters that are variable, H1 or H2 or Q1 or anything. It should be in terms of the physical parameters. Now, when we talk about the equations, what we have seen so far, Shabab, if you remember, we were talking about a nonlinear equation. Sometimes we need to linearize this equation, but about some point. A nonlinear equation can look like this one here in the graph as a function of x, the function between x and z. And you can see the equation is, it looks like a parabola now. So it is a nonlinear equation. We need to linearize it. We make linearization about operating point, which means at which point we want to linearize it, it will be here or here or here, but we cannot linearize it yani straightforward, but we need an operating point. So if we take that, if we consider that we have operating point, which means at which we are looking for to linearize it, we can do the, it is called the operating condition or the operating point. Let's take this point, which is x bar and z bar. So the x point x is x bar, the z point is z bar or y bar, it's up to you. If we do the Taylor series expansion for this function, z is equal to f of x, it can be written like this. Z will be equal to fx bar, operating point x bar, plus the first derivative of x minus x bar at the operating point, plus 1 over 2 factorial, the second derivative of f with respect to the x squared at the operating point, and so on, plus 1 over 3 factorial, and so on. So where df over dx is the differentiation of f with respect to time, and the second derivative of f with respect to time also at the operating point x bar and then z bar. If the variation of x minus x bar or x bar is small, so x minus x bar will be very small. So we can neglect the higher order term. For example, x minus x bar. If x minus x bar is 0.01, so this is x minus x bar, x minus x bar is small. So if this is x minus x bar is 0.01. So if we take x minus x bar square, it will be even smaller. It will be something like this 0.001, smaller. So if it is even smaller, so it will have neglect value. We can neglect its value. So if we neglect this term in this case, if we higher order term can be neglected, this term will be neglected, and we will end up by having only this equation. So z will be equal to fx bar plus df over dx, x minus x bar. which can be written in this form. Z will be equal to Z bar plus M x minus x bar, where M here is the value of df over dx at x is equal to x bar, which is basically the slope. If you look to this equation, this equation of a straight line, it's not only a straight line, but it is the slope at this value. If you draw the slope here for this one, you will find that this is the slope, the equation of a slope at this point. So linearizing, no, it's not Newton equation. What's جاب ما إيش جاب Newton equation هنا. So it is the tangent to the origin here. So when you linearize the equation, it means write the equation of the tangent. Writing the equation of the tangent, this will give you exactly the linearized. Suppose you have a nonlinear equation, f is equal to fx bar, or f of x is nonlinear equation given to you. The linearized equation, just write the linear, this is the linearized equation. So which means find the equation of the tangent line at the operating point. Okay, Shabab? At the operating point. Well, Shabab, is it clear, this one? So M here is the slope at x is equal to x bar, and z is equal to fx bar, the value of x bar at this one. So at x bar, the function has the value z bar, and the point z minus z bar is, this is the equation of a straight line where the tangent has a slope of m is equal to m. Will you recognize this equation here? So this is what we are saying here. The equation represents a linear mathematical model for nonlinear system given by this. It represents the tangent line with a slope m to the curve z is equal to f of x at the operating point x bar and z bar. Similar idea can be represented for an equation that has several variables. Let's take when we have two variables, z is equal to fxy, where x and y are variables, or are two inputs if you want. Since we are studying the system dynamics and control, we are studying the values for which we are going to linearize. So our linear point here, or operating point, will be x bar, y bar, and z bar. So it is in the space. And the function will be z is equal to fxy. And now we do the same thing, the Taylor series expansion about the operating point. It will be z is equal to fx bar y bar plus partial derivative of f with respect to x minus x bar, plus partial derivative of f with respect to y minus y bar, plus the higher order terms. So for small values, or very small values for x bar and y bar, this higher order terms can be neglected. So this can be neglected, and we can write z can be written like this: z is equal to fx bar y bar plus d over dx of x minus x bar. This will be the slope. This will be the slope in the direction of x, which is called m in this case. And df over dy will be the slope in the direction of y, and we can write it like this. And then we can write our equation: z minus z bar will be m x minus x bar plus n y minus y bar. Well, here, remember, x bar, y bar, z bar are the operating point. M is the slope on the x direction, and n is the slope on the y direction. If we got an example here to be solved about this one, they are asking us to linearize the equation z is equal to xy in the region x is less than 7 and greater than or equal 5, and y is between 12 and 10. Find the error if the linearized equation is used to calculate the value of z when x is equal to 5 and y is equal to 10. here شباب we have infinity of values that satisfy this equation, since we have inequality between this and inequality here. So if we take, for example, our operating point to be x is equal to 6 and y is equal to 11, it will satisfy this one. So we have infinity of solution, but we have chosen these values because they are inside this interval. They lie inside this. Y11, y bar is equal to 11, it's here. And x bar is equal to 6 is here. Anybody can choose 5.5 or 6.5 here, and can choose 10.5 or 10.75 or 11.5 or 11.75, they will satisfy. We just selected x bar is equal to 6 and y bar is equal to 11. So the value of z bar here, z bar will be equal to x bar times y bar. X bar, which selected 6 times 11, this will give you 66. So z bar will be 66. So we obtain the linearized equation for x bar is equal to 6, y bar is equal to 11, and z bar is equal to 66. Now let's see the slope at the given values. The slope at the given values, our linearized equation is this one. Z minus z bar is equal to m x minus x bar plus n y minus y bar. Z bar, we just found it to be 66 here. X bar, we selected to be 6. This one is 6. Y bar is 66. So all we need to do is to find what is m and what is n. M is the slope in the x direction, and n is the slope in the y direction. Z bar is 66 here, and y bar is equal to 11. So now if we differentiate the equation here, if we differentiate this equation dz over dx. Ali Al-Sawbadi, can you please tell me what is the differentiation of dz over dx here? Ali Al-Sawbadi. Ali Al-Sawbadi, can you please tell me what is the differentiation of dz over dx? Ali Al-Sawbadi. Hani Al-Rumeh, can you please tell me what is differentiation of dz over dx?
No.
Z is this one. Z is equal to xy. If we differentiate it with respect to x over dx, what it gives you?
Y.
Y. أحسنت جزاك الله خير يا ولدي بارك الله فيك وأحسن الله إليك. So this is y. But شباب احنا we want it at the operating point, يعني at y bar. Y bar كم قيمتها؟ y bar كم قيمتها يا شباب؟ 11 صح؟ y bar will be 11. Similarly, the n will be dxy over dy. Hassan Al-Jarudi, can you answer this question? Dxy over dy. When we differentiate xy, we differentiate it with respect to y. What we will get? Hassan Al-Jarudi. Hassan Al-Jarudi is not here with us.
أنا here دكتور.
طيب جاوب حسن الجارودي. When you differentiate dz over dy and differentiating in a dz over dy, this is a z, this is the equation of z is given to you in the first line of the problem. If I differentiate dz over dy, شباب, dz over
will be x.
Yeah, عليك نور dz over dy will be equal to
y. Yes.
طيب. At the operating point, it will be x bar. X bar, we know it is 6. So m is equal to 6 and m is equal to 11. Now we substitute in our equation here. Z minus z bar is equal to mx minus x bar plus ny minus y bar. So we can write it now. Let's substitute z minus z bar, يعني z minus z bar كم لقيناها شباب؟ z bar لقيناها 66. So it will be Z minus 66. I'm working here, Shabab, in this equation. Z minus 66 will be equal to M. M حصلنا عليه to be 11 times X minus X bar. bar كم لقيناها 6 plus N is here. N كم لقيناها شباب؟ N to be 6. Y minus Y bar معناته Y minus Y bar 11. So at the end of the day, we will have here Z equal to 11x from here, 11x plus y plus 6y, and then we have minus 66 from here, minus 66, and then minus 66 ثانية, minus 66, and then نرجع plus 66 the other side. So this will cancel with this, and we get 11x plus 6y minus 66. This is our equation. This is our equation. The linearized equation is this one. Now, if we substitute when x is equal to, he asks you substitute when x is equal to 5 and z is equal to, or y is equal to 10, what will be the value? When z is equal to, and x is equal to 5 and y is equal to 10, this is what we have. Z will be equal to 11x plus 6y minus 66. So it will be 11 multiplied by 5. This one we have, and we have x is equal to 5, x is equal to 5, and y is equal to 10. So 11 multiplied by 5 plus 6 multiply, y will be 10 minus 66. What is this value, Shabab? Here 55 plus 60, 55 plus 60 minus 66. What is this value equal to? This value will be equal to 49. 49. Now, if we compare the non-linear value, z is equal to x times y, it will give you 5 times 10, 50. The linearized value is 49. The non-linear value is 50. What's the difference, or what is the error? The error will be 50 minus 49. In percentage, it will be 50 minus 49 over 50. It will give you 2%. And which is good when we linearize the equation. This is an example of a nonlinear equation or system. When we linearize it, we got 2% the error. تفضل يا هاني.
زاد فضلك. بس يا دكتور 6 و 11 we choose it, right?
Yes, in 11 you choose it, but you can choose any value. And I choose.
It has to be integer. It has to be integer, or I
no,
can.
Not necessarily.
Okay.
Not
clear.
You have to take them within this interval.
Okay.
Within. Sometimes هو يقيدك يقول لك this value at any point. But هنا, since they are within the interval, no problem. The solution, of course, this solution or this problem accepts infinity of solution. عدد لا نهائي من الحلول. لأنه you have an interval هنا. You can choose any value that lie within the interval. Is this clear?
Yeah, could be asked the error should be like less than 1% or 2%. So
no,
he
not
has to force me.
Not necessarily. You can take any point. لأنه هو not ask you the error. هو just قال لك find it. احنا whatever it is, you can put it. Any question, شباب? So let's move to another problem. Here, consider the liquid level system shown in this figure. The curve head versus the flow rate is shown. This is the curve. This is, as you can see, the flow rate, Q. And this is the head, which is H. So the relationship is shown here. Assume that steady state, the liquid was 4 times 10 to the minus 4. and the steady state head is 1 meter. So here at the steady state value at this point, the head was 1 meter and Q was 4 times 10 to the minus 4. At time t is equal to 0, the valve is opened. They opened the valve, and further the inflow rate is 4.5. يعني the inflow rate ارتفع من 4 to 4.5 10 to the minus 4. يعني الفلو rate زاد إلى غاية it was 4 and then it is 4.5 10 to the minus 4 meter cube per second. Determine the range, the average resistance R of the flow rate. The flow, شباب, the average resistance, if you remember from the beginning, we defined it to be delta H over Q. Is that right, شباب? Over delta Q. If you look in, delta H is this amount, 1.266 minus 1, over delta Q. Delta Q here is 4.5 minus 4. So this is the resistance. واضح شباب, clear? And then after that, he asks you to determine the change in the head as a function of the time. The capacitance of the tank is given to be 0.02 meters square. So the resistance will be simply the change, as you can see. And we found it. We found the delta H over delta Q. R will be dH over dQ. And 1.266 minus 1, which is this one, over 4.5 minus 4, which is this one. It will give you 0.532 10 to the power 4, which is second per meter square, the resistor. So this is the equation, or you can use this equation if you want. You remember, we gave you the equation for the flow rate. You can find it also. So here now they are asking us to find the equation for the flow rate. The flow rate during the tank, if you have, this is the tank and this is the resistor here, and we have the flow rate. So this is C, this is H and C. We said, so the change in volume will be simply a Q in minus Q out, the Q out here. So C dH over dt, the change in volume. So this one, remember the change in volume, change in volume, change in V will be Q in minus Q out. This is Q in and this is Q out. And the resistance here is given by H over Q naught. This is H and then Q naught. So R will be simply H over Q naught. So we can substitute from here. C dH over dt is equal to Qi minus Q naught. Q naught is H over R. So we can simplify this equation, or we can rearrange it. It will be RC dH over dt plus H is equal to RQi. Here, Qi is the input, H is the output. You substitute R because we found R. You have C. You have Qi. Qi was given to us, if you remember, in the beginning. So into the last equation, this will give you this, or will give you this one, which is a first order system of H with respect to time, because this is the first derivative. Now, if you take the Laplace transform of this and then you solve it, you will find that this one will be S H of S plus H of S will be equal to this. If you take the inverse Laplace transform, you will get a function that is of this form. So this is when we take Laplace transform of both sides. This will give you this, or H of S will be this one, just Laplace transform of this one. And then if you take the inverse Laplace transform of this one, this will be 0.2661 minus exponential minus t, which will go like this. So at the beginning, it is 0, and then it goes like this. With respect to time, it will be constant. So H of t with respect to time will be constant. And this value is 0.266. So this is the time. And this is H of t, how it is. After some time, it will go to the steady state, and the height will be a constant. Any question شباب before we move to something else? Any question? So if you don't have any question, let me just take the attendance. وجزاكم الله خير على حسن انتباهكم. Let me just take the attendance, please. So who is with us today and who is not? علوة منير معنا اليوم. أهلين منير أهلين. الدغالبي فيصل الدغالبي. فيصل كيف حالك يا فيصل؟
الحمد لله تمام. كيف حالك دكتور؟
أهلا وسهلا. شباب المسعودي عبد العزيز
موجود يا دكتور.
أهلين عبد العزيز أهلين. ولا ماجد الملاح ولا الملاح؟ ماجد كيفك اليوم؟ أحطاني حسين.
اهلا يا دكتور.
كيف حالك حسين؟
الحمد لله بشرنا عنك.
الحمد لله الله يبارك فيك يسلمك. المحمدي عبد العزيز كيف حالك؟ معانا اليوم؟ ما شاء الله محمد دائما مبتسم ومن ما شاء الله. قحطاني عبد الكريم. أهلين عبد الكريم كيفك عبد الكريم؟
خير الله يسلمك دكتور.
شهري علي معانا اليوم.